Hey guys, Miss Nguyen here with our video for the slope and y-intercept from a graph notes. Right? So, let's dive right in, shall we? Okay, so slope, which we represent with the letter M. Let's use the color red. With the letter M is the rate of change in a relationship. So in that example that I always use, working minimum wage somewhere, $10 an hour, that $10 is the rate of change. Every hour you get paid $10 more, so if you were to make like a graph of your pay versus how many hours you worked, it would, each point from whole number to whole number would be going up by 10. That's the rate of change. Okay, so slope is a ratio of the change in y divided by the change in x. So I'm going to write that and then draw the line in the middle. So change in y divided by the change in x. Okay? Now in proportional relationships, and we've covered that, in proportional relationships we find m by using this ratio y divided by x. Now, we're still doing change in y over change in x with proportional relationships, but because the rate of change is constant in a proportional relationship, we don't have to really calculate the change in y. We could pick any point, take the y value, divide by the x value, and you'll get the same m. Remember how when we did the tables, no matter which point we picked, if it's proportional, all the m's should be the same. So same thing here. Okay, so that's only for proportional relationships. And a lot of what we're going to do, starting today, are going to be non-proportional relationships. Okay? When we're looking at the graph of a line, slope describes how steep that line is. Okay? So if you've ever been to Six Flags, they have those two roller coasters. Well, they have roller coasters at Six Flags, right? And when you are on part of the roller coaster that's like kind of flat, that's steepness, right? And it doesn't feel too bad, but when you get to a part where there's a sudden drop, that's an area that's really steep. Or a lot of times we read a book or something and they say, oh, the cliffs were so steep, don't fall off, or oh, the stairs are so steep. Things that are steep are at more of an angle. Like if it was straight up and down, that is super steep. That's as steep as it gets, because that's like a sudden drop there. Whereas when you have an angle, the steeper it is, the more angled it is. If you have zero slope, so a line with a slope of 0 would be completely flat. So like a straight horizontal line, right? Because if it's flat, then there's no slope. Whereas as we increase the slope, our angle of our line starts getting more and more steep as it approaches, vertical, right? And so when we're looking at a graph, slope, when you're looking at, okay, visually, what is slope? Slope is describing how steep the line is. Now there's 4 basic types of slope, and we're going to go over these, starting from this top upper left. Okay? This is a positive slope. Right? Positive slope goes up from left to right. Okay, so you can read graphs the same way you read sentences. Like the chicken crossed the road, you read each word from left to right. So you read graphs the same way. So you can trace the graph with your finger, see where the graph is, and you want to trace it with your finger from left to right. And if you trace it with your finger from left to right and the graph is going up, then that means the slope is positive. Right? You have a positive slope, like the example, $10 an hour, you're getting more money every hour. That's positive change, right? Now, if you trace the line and it goes down from left to right, then that would be a negative slope. So this one here, this is negative slope. It goes down from left to right. Okay, so we see when we trace this line here, from left to right, it is going down. If it goes up from left to right, it's positive. If it goes down from left to right, that is negative slope. Okay, now we've got these two down here. This first one is a prime example of what I said up here. A line with a slope of 0 is flat. This is a flat horizontal line. We call this zero slope. It is a flat horizontal line. The slope is 0. Okay. Now this one, this is a vertical line. This is what we call undefined slope. This is a vertical line. Straight up and down. This is, all the slope. Remember when I said straight up and down would be the ultimate steepness? Like if you fall off a cliff that is that steep, you're just going to go straight down. We call this undefined because there's no good real world example for this, right? Like I had one for positive slope. For a negative slope, you could talk about something like, the relationship between somebody's age and how healthy they are, because usually the older you get, the less healthy you get. Your health starts to go down. The zero slope, that's something where no matter what x is, y is the same. So an example of zero slope could be something like the relationship between days and how much money you have. If you take a $10 bill and slip it under your pillow and just leave it there, never add any money to it, well, no matter how many days pass by, you'll still have $10. So that's kind of a situation like this. No matter how many days go by, how many x may change, but y does not change, y stays the same. So that's an example of a zero slope. But there's really no real world way to describe a relationship with an undefined slope that I can think of, because that's just a physically impossible, weird kind of situation, because x is supposed to be independent. So if you have a vertical line, that's why we call it undefined. It's just strange. It's an anomaly. Okay. Now we are going to talk about the y-intercept. So these two, the zero slope and undefined slope, are the two that students get mixed up often. So here's a kind of a nice way that you can use to remember which one is which, right? Okay, zero slope is a horizontal line. Both of those words have a z in them. Okay, undefined slope isn't. So by process of elimination, if you can remember, zero slope has a horizontal line. Then the other one, the vertical line, is undefined. Okay, so recap. Positive slope goes up from left to right. You trace it with your finger, it goes up, that's positive slope. If you trace the line from left to right and it goes down, that is a negative slope. If it's a horizontal, flat horizontal line, that's zero slope. If it's straight up and down vertical line, that is an undefined slope. Okay? So, now we're going to move on and talk about the y-intercept. Luckily, that one is a lot easier to figure out. The y-intercept of a graph is the value of y when x equals 0. Okay, so it answers the question. All right, when x is 0, what is y? That answer is our y-intercept. So visually, when we're looking at a line, visually we can find the y-intercept on a graph by looking at the point where the line crosses the y-axis. All right? Where the line crosses the y-axis. Now the word intercept, to help you remember that, you think about in football, when somebody throws the ball to pass, and the other team catches the ball, stops the pass, pass incomplete, that's an interception. You intercepted the ball. So you want to think about, okay, for the y-intercept, this is where the line of this graph is intercepted by the y-axis. All right? So here's a graph. Let's figure out what that looks like. So we have two axes here. Remember, our y-axis is the one that is up and down. This is our y-axis, this line going up and down. Side to side, that is the x-axis. So what you want to remember is when you compare the letter y to the letter x, the letter y is kind of skinny, kind of vertical up and down, whereas the letter x is a bit wider. So that's one way you can think about it. Okay, so erase that. we have our line here. Here's the y-axis, here's the x-axis. So we want to find the y-intercept. That is where the line crosses, where it touches the y-axis. So here's the y-axis, here's our line, here's our y-intercept. It's just one point right there. Okay, so it's the one point where the line touches the y-axis, not the x-axis, this is not it, the y-axis. Okay, isn't that much easier? Okay, well, finding slope from the graph is a little bit more complicated. Okay, to find the slope of a graphed line, we need to figure out the change in y and the change in x. Okay, change in y and the change in x. Remember all the way back on the first page where I said slope is the ratio of the change in y over the change in x? That's why we need to figure out what those are so we can find the slope. Okay, so to do that, there's a couple steps. First, we want to pick two perfect points from the graph. So we don't want to pick points that are in the middle of the grid boxes. What does that mean? Or let me show you an example. So let's pretend that this is a graph. This is our x-axis here, so let's count 0, 1, 2, 3. So our x-axis, 0, 1, 2, 3. Here's our y-axis, right? We want to pick points that are right on corners. So like this, for example, this is a perfect point because it's right smack dab in the corners. So when we look at this point, we can tell for sure that the coordinates for this point are 1, because 1 for x, 2 for y, so 1, 2, because it's right here. There's another example of a perfect point like this one. It's on the edge, but you can tell this would be 0, 3. So these are two examples of perfect points. So we want perfect points that are right smack dab in these corners where corners meet, because that's perfect, okay? Now, let me show you what I mean by points that aren't perfect. Like this. See how this is just floating in the middle of this box? What is x here? It could be 0.5, it could be 0.4, we don't really know. It's not very exact. Well, that's why we don't want this. Here's another example. This is on one of the lines, but you can't say it's in the corners. So while we might know, okay, x is 2, but we don't know what y is. Is it 1.1, 1.2, 1.3? Like we don't know. So these here are examples of these are not perfect points. And I highly recommend in your notes to make these different colors. I use the same colors I use, that'll help. These are not perfect points. If you try to do slope with these, you will make Miss Nguyen very sad. Look at that. We don't want points like that. We want perfect points that are right on corners. Okay? So after you've got your two perfect points, we're going to use them in this formula. M equals y2 minus y1 divided by x2 minus x1. Now the nice thing is you do not have to memorize this formula, because whenever you're taking the STAR test or whatever standardized test or quizzes in class, this formula will be given to you. However, you need to know how to use it, otherwise this is not very useful for you. Okay, so I'm going to show you how to do it. Now, you might be confused as to what all of these little things mean. Well, here's the thing. Remember, we picked 2 points. So if we have 2 points, that means we have 2 x's and 2 y's, right? So this formula is basically designating which x and which y. Like this is saying the y coordinate from the second point minus the y coordinate from the first point divided by the x coordinate from the second point minus the x coordinate from the first point. Okay, so that's how it is. Once we pick our 2 points, we can label them and then we'll know exactly what numbers go where. So let's see what that looks like. So here's our examples. Let's go ahead and do this one on the left. It says let's find the slope and y-intercept for both of these graphed lines, right? So here's our line, here's our y-axis and our x-axis. Let's start off by finding the y-intercept because that's the easiest one to find. So here's our line, here's our y-axis. Where does this line cross the y-axis? Aha! Right there. So at this point, x equals 0, y equals 2. So we can scroll down, write in this answer. That means our y-intercept is 2. Okay? Now we have to move on to the slightly more difficult part of finding the slope. All right? So for the slope, we need to pick 2 perfect points. Good news is we already have one because the y-intercept is a perfect point. We know that this y-intercept is 0, 2, because at this point x is 0, y is 2. That's what a y-intercept is. Okay? So now we just need to find one other point. I'm going to do this in a slightly different color. So let's find one. Okay, see, this is bad. This is not a perfect point. This is not a perfect point, so we want one that's right in the corners, like, say, this one. This is a nice point. So this point, the coordinates, if you are still, not as confident picking out coordinate points, when you have your point, you can just draw a line down until it touches the x-axis, and a line to the side until it touches the y-axis. And then that will show you, okay, at this point, x is 6, y is 5. And then to neaten it up, we can erase that. So this point is 6, 5. Remember, x first, x, y, so 6, 5. Now we have our 2 points. Let's go ahead and label them, right? Now you need to decide which one is the first point and which one is the second point. Like we do this is first point, this is the second point. You could also do this is the second point, this is the first point. It does not matter which one is which, you will get the same answer, I promise. Okay? But it's important that you stay consistent. Here's what I mean. If this is the second point, then this is our second x. So this is x2, and this is our second y. This is our first point, this is our first x, x1. This is our this is our first y, see? Be careful. Right? Now, if you had the points switched, this is 1, this is 2, that's fine, but then these need to change too. Now this is x1, this is y1, this is x2, this is y2. So what you want to make sure of is that all the numbers, your 1, 1, 1 matches, 2, 2, 2, 1, 1, 1, it matches up. Okay, because if not, then you're going to put your numbers in the wrong place and bad things will happen. Right? Now we have our numbers. We know what x1, y1, x2, y2 are. We can now use our handy-dandy formula, which I said you don't have to memorize, but you're going to use it so often that you will memorize it. M equals y2 minus y1 divided by x2 minus x1. So all we have to do is take these numbers up here and put them into the right slots. Okay? Our y2, what is it? Aha! It's 2. So 2 minus y1 is 5. 2 minus 5 divided by x2 minus x1. x2 is 0. x1 is 6, so 0 minus 6. 2 minus 5 is negative 3. 0 minus 6 is negative 6. When you have a negative and a negative, you divide a negative by a negative, they cancel out. This becomes positive. And now we have to reduce this fraction. Remember, if you don't remember how to do that, you can type 3 over 6 into your Desmos calculator and it'll do it for you. But if you know how to reduce this fraction, you divide the numerator by 3, you divide the denominator by 3. This turns into 1/2. Oops. So that means our slope is 1/2. Alright? Now once you get the hang of things, it won't take quite this long every time. Okay, so let's do the second example. And if you want to pause and try it on your own, go for it. We have another line. Here's our y-axis. Here's our x-axis. Where is the y-intercept? Here's the line. Aha. Our y-intercept is negative 4. Let's find the slope. There's one point. Let's find another perfect point. Here we go. Right on a corner right there. I'm not drawing these points very nicely. Here we go. Right? So this point here, this is 0, negative 4. This point here is -4, 5. Now let's label. Okay, say this is point 1, this is point 2. This is x1, y1, x2, y2. Now we're ready for our formula. M equals y2 minus y1 divided by x2 minus x1. y2 is -4. y1 is 5, so -4 minus 5. x2 is 0. x1 is -4. Okay? -4 minus 5 is -9. Okay? Do you know what happens when you subtract a negative? Just like with multiplication and division, if you subtract a negative, you have two minus signs, put them together, they make a plus sign. So this is the same thing as saying 0 plus 4. So on the denominator we have 4. We can't reduce this fraction anymore because 4 and 9 don't have any common factors. So simply put, our slope is -9 over 4. Alright, hopefully you're getting the hang of it. Okay, so the next page is full of some practice problems. Some things I would like you to consider as you do these. Number 1, you can probably tell this is a horizontal line. It means it has 0 slope. Does a 0 slope line still have a y-axis? Or sorry, does the 0 slope line still have a y-intercept? Yo. It still crosses the y-axis. So it'll still have a y-intercept, and we already said the slope is 0. Right? So that's something to keep in mind. Now, here we have a vertical line that's undefined. So does this cross the y-axis? The y-axis is over here. Right? So this is one where you would say, NA, this is not available, does not have a y-intercept. So that's a bit of a trick question. The rest of these, as you pick your perfect points and calculate, you should be able to figure out the slope. And, if you want to, just to help check your work, before you start, you can trace the line. This is going, like number 2, this is going up when you go left to right. This is a positive slope. So if you're calculating your slope and you get a negative answer, then you know you messed something up, So use that to help check your work. Okay, so this will be your independent work that you're supposed to do when you're done. If you would like to check your answers with me or check with a friend, you can do that. But that's how you do these. Okay, so we'll get some more practice in, but hopefully this video was useful for you. Please make sure that you pause to copy notes down. You can rewind, watch this video as many times as you want, and if it's still confusing, let me know. We'll work something out, right? Okay, so I will see you in class.